All right, good morning, guys. This is Mr. Aragon. I'm going to be going over mole problems on your homework. Keep in mind, I won't go over the whole thing. I'll go over just enough to help you get started. So keep in mind also on your work plan, there are video links to every single one of these to basically solve similar equations or similar questions. So it's not going to be on your printed work plan, but it is going to be on Drive, and you can just click on those links. All right, let's get started. So molar mass, I want you to think of like molar or a mole is basically like a unit of measurement. So I think about it as kind of like a dozen. So we're going to talk about dozen mass, right? So if you have a dozen cherries, you're going to have 12. If you have a dozen apples, you're going to have 12. The only difference is going to be the mass, because obviously a dozen cherries is going to weigh less than a dozen apples. So part number one, use the periodic table to find the molar masses of the following. So if you look at HCl, keep in mind, I did get some feedback from students, and they were asking me, how do you know if it's an element or not, or if it's two elements, right? If you have a capital, if you have a capital letter by itself, that's a single element. If you have a capital and a lowercase, that's one element as well. So if you look at N, capital N, lowercase a, this is one element. If you look at P and O, these are both capitalized, so this is one and this is one. So you have three different elements. Okay. All right. So what is a molar mass of HCl? Well, in order to find this, you look at your periodic table and you look at the atomic masses. So for H, I have a periodic table over here. H has an atomic mass of 1, and I usually round. So I'm gonna put a 1 there. And then Cl has an atomic mass of 35.45, so I'm gonna do 35.5. Why not? So your answer is gonna be 31 plus 30. 35.5, which is going to be 36.5. If you want to round up to 37, that's okay. I usually, if it's like 0.4 or 0.5, I'll usually round it up to 0.1 or 0.2. So in this case, I rounded it up to 0.5. Now let's look at this one. Potassium carbonate, so K2CO3. I know that the atomic mass of K, going to be 39.09, so I'm just going to round it to 39. So I know that I have 39, but since I have a 2 right here, I'm going to add another one, so it's going to be 39 plus 39, and then I know that the atomic mass of carbon is 12 plus 12, and I only have one of those, 12, plus O3, right? So plus 16, we're going to say, for oxygen. So plus 16, and since we have 3 oxygens, we're going to do it 3 times, plus 16 plus 16. Okay, and you add those up. Okay. Oh, moving on to this one. This is my favorite. All right, so we have Ca, which is one element, and then O, which is another element, H, which is another element, and you have a 2 on the parentheses. What this means is, like, it's basically you're going to be distributing this 2. So this gets distributed here. This gets distributed here. So you have O2, H2, basically. So you look at the atomic mass of Ca. So good old calcium, 40. And then the atomic mass of oxygen is 16. But since you have 2 of them because of this guy, you're going to do plus 16 plus 16. And then because you have 2 hydrogens, you're going to do plus 1 plus 1. And you add these up, and that's your molar mass. All right, let's get to the nitty-gritty of some calculations. Mole conversions. So work each of the following problems. Show all of your work. Please show all of your work. Please do not just give me the answer, because you will see the furious side of Mr. Aragon when he comes back on Tuesday. All right, so how many atoms are in 6.2 moles of aluminum? Okay, before we even start any of this good stoichiometry or good conversion, what we're going to do is I'm just going to write a key for myself. I know that 1 mole of anything is equal to 6.02 times 10 to the 23rd. Okay? And that's, so in 1 mole of anything, so in 1 dozen of anything, I know that I have 6.02 times 10 to the 23rd either elements or particles or molecules. All right. So how many atoms are in 6.2 moles of aluminum? So we know that we always start with what you have. So I have 6.2 moles of aluminum. And then what are you trying to get to? How many atoms, right? So if I have 6.02 or 6.2 moles, and this is very important that you write it down. I usually put it over 1. And then start your dimensional analysis. And I'm trying to get to atoms, right? So I'm going to put atoms up here. And I know that if I have moles up here, I'm going to put moles down here. And I know that 1 mole of anything is equal to 6.02 times 10 to the 23rd. Sorry about the writing there, guys. So what you do is you would multiply across. So you would multiply this by this, and then this by this, and then you basically end up with this, right? So 6.2 times 6.02 times 10 to the 23rd is 0.02 times 10 to the 23rd divided by 1 times 1, which is 1. So this is going to be your answer. So you can enter this in a calculator. Let's see. Ooh, convert 5.3 times 10 to the 25 molecules of CO2 to moles, right? So what do I have? I have 5.3 molecules or particles. And then how many moles of CO2, right? So because you're trying to go from molecules to moles or atoms to moles, same thing, this element does not matter because we know that 1 mole of anything is going to equal 6.02 times 10 to the 23rd, right? So what I do is I always start with what I have, 5.3 times 10 to the 25th over 1. And then I'm trying to get to moles, right? So I'm going to write moles up here. And then because I have molecules down here, I'm going to write molecules down here. Okay. I know that in 1 mole, I have 6.02 times 10 to the 23rd molecules. So what you do is you basically multiply across this way, you multiply across this way, and you'll find that you're going to end up dividing this by this. And that should give you your answer. And your answer is going to be in moles. All right, let's do another one. So I'm not going to do this one for you, but this one's pretty much the exact same. Convert 3.55 moles, not molecules, moles, to formula units. So formula units is another name for atoms or particles or molecules. So basically what you're going to be doing is the exact same thing that we did in this first one right here. All right, let's flip the page. Perfect. All right, now we're getting into some cool stuff. So convert 3 moles of As2S3 to grams. So in order to do that, we're going to actually have to figure out some molar masses, right? Because you want to know how many moles are in, or I'm sorry, how many grams are in 3 moles of As2S3. So this is basically saying how many grams are in 2 dozen or 3 dozen apples, right? We know that the weight of apples is different from that of cherries or bananas, so we're going to need to factor in the molar mass, or the mass of the dozen, right? So when we do that, we always start with what you have. So we have 3 moles of As2S3. I usually put it over 1. And I know that if I have moles on the bottom, or on the top, I want moles on the bottom so I can cross them off.